Hello, I'm Christina Pinetta.
Hello, I'm Bradley Chow.
I'm Sebastian.
I'm John Yakuna.
This is our car.
Streamline.
Please start laughing.
This is called Streamline, based on its streamline. The length is 150 millimeters, including the hook from longest point to longest point. The width is 32 millimeters, and the height is 50.
So taking the model car that we created, we are going to be testing the drag force applied when in a wind tunnel and calculate the drag coefficient. We are going to be doing the same thing for a provided TA car and comparing that drag coefficient with ours.
Model, our preliminary design was to have a front angle plow to reduce drag.
It creates downforce by having a frontal slope, as well as it has a small groove running down the middle that sort of creates a Venturi effect. Also helps pull it downwards, so it allows us to stay stable and attach to the plate. It has a lot of streamlines just to keep it as much aerodynamic as possible, usually taking a very high surface area, putting it at an angle, reduces the overall coefficient of drag. In this case, we have a pretty large surface area, 400 square millimeters for a frontal profile, which if we were to cut it straight down, it would be roughly 1,500 square millimeters.
So some of the principles that we learned from our experimental observations and calculations were, first of all, that the importance of other factors, not just the frontal area and the resulting drag force, because even though the frontal area was only was an eighth of the TA's car, we had a fourth of the drag force. So it was kind of interesting to see how it's not just the frontal area that plays a part, even though that was the focus of the experiment.
The information that we learned from this project is applicable in a lot of fronts. We could, as aerospace engineers, we could utilize this in the field of building rocket design, as drag is an incredibly important factor to the success and trajectory of a rocket and its ability to even get off the ground. In other ways you could use it, mechanical engineering wise, in design of hypercars and high-speed vehicles, so that they're getting their optimal speed and not having such a high drag.
So when it comes to improving our design, we decided really not to, because we designed it this way from day one, ran plenty of tests, and surprisingly it was the first idea that worked. Oh, but did though add a Venturi effect through maybe to help it in my latest iteration.